Hello, my name is Christopher Pereira. I am the project leader here for our capstone class at Saratoga Springs High School.
Hello, I'm Samantha. I am the project manager for our class.
Hi, I'm Declan, and I do most of the CAD modeling for our group.
Hello, my name is Braden. I organize all of our PowerPoints, put them together, and make them nice and organized.
While skiers and snowboarders make their way down the mountain, they often face the same problems. Winter sport participants have expressed their issues in forums, videos, and blogs around the world. Rosenbaum Law Firm states that over 600,000 people get into skiing-related incidents every year, and according to getnux.org, the use of protective equipment can reduce the risk of injury by up to 43%. Visibility issues due to icing on skiers/snowboarders' goggles are a major part of these statistics. Current solutions are often ineffective, difficult to use, or too bulky to be practical on the mountain.
So some of our starting research that we made when we were first looking into this issue was, there has been a decrease in rate over time. The rate at which skiers get injured is still pretty high. It's about 2.24 injuries per 1,000 skier days is the average. The severity of injuries, there's a bit of a range, but sometimes they're severe enough for hospitalization and can have a lot of longer-term negative effects. 12.8% of the injured population require emergency transportation, which is still a pretty major concern. Obviously, we want to reduce these statistics. And 196 patients, most of which were skiers, were identified as having major traumatic injuries. 43 patients required intensive care unit support. So many of them were related to falls and collisions with natural objects, which can help be reduced by higher visibility, so it's easier to see these objects. We also sent out a survey. We asked a bunch of different people. We asked on forums, and so to kind of gauge how many people in this area kind of deal with icing and fogging and how that affects them.
So, and then after we did our research, we went into some previously developed solutions. We found 3 different ones. None of them really quite solved what we were trying to, our goal, which is to clear icing and snow, while the other three that we found mostly solved the problem of fogging.
The other thing that we noticed was a lot of them tended to have batteries and things near your head or your chest, which could potentially be dangerous in a fall. In order to make sure that we aren't just solving a problem that's already been solved, or that we're solving it in a different, more intuitive way that's easier to use, we looked heavily into it, and the solutions that exist don't solve both icing and fogging, and there's potentially scraped lenses, or it involves a power source right near your head. It only addresses half the problem, essentially. And potentially scraping lenses could lead to impaired vision, which is the problem we're trying to address, so that's not necessarily ideal. And we have compiled, a bunch of different patents, some of which we have laid out on the PowerPoint for you, summaries, numbers, sketches that we can find to kind of show our resource here. We also surveyed a bunch of people and their reviews of products and how it works and affects them.
Some of the ethical considerations that we had to take into account are primarily centered around the safety of ski goggles. The product users expect the goggles to be safe to use while provide an anti-icing solution as advertised. Our solution must keep people safe and comfortable. It will be used in the natural environment, so we must prevent any parts from coming loose on the ski hill that could potentially end up harming animals or other people in the area, especially because we will be working with at least some plastic. There's also a possibility that our solution will contain an electrical component, so we must ensure that the component is safe to be near a person's face.
So some of our early concepts include things like a cloth that has a microfiber edge on it, and what we were thinking is having you pull it out of a heated case so that when your goggles are icing over, you're clearing your goggles away, and then with the other side and the microfiber cloth, you can wipe away any water or frozen bits of ice that remain. Our middle concept is a capsule with a little roller inside that allows you to move a microfiber cloth in 2 different sections so that one section is always dry for when you need it, and there is a removable scraper on the side that acts as a cover to the microfiber cloth so that when you need to use the product, it all functions as one. So you flip the scraper open, scrape the ice away, and then clean it with the clean side of the microfiber cloth. And our third solution was a sticker design where on any goggles that you already have, you apply like a 10-pack of stickers that when the front ice is over, you could peel it off and keep doing that until you're down the mountain.
One of our main goals through designing our product has been to make it easy to operate for any type of user, whether they're wearing mittens or regular 5-fingered gloves. We have to make sure that the parts are easy to move, so it feels clean and like it's a well-structured product. Our parameters have been that materials need to be durable and semi-lightweight. This product's going to be somewhere on your body, so you don't want to be carrying around a heavy load like some of the previous attempts through our patent research have been. And as well, the material scraper should be sturdy enough to break ice, but not a material that is going to scratch your goggles or ruin any other part of the product.
Some of our design goals is prioritizing the safety of the user when using the product and the various types of potential customers. Our design must be intuitive for users that may have never encountered icing when skiing or have never skied before. We must take into consideration the performance and durability of the product because it will be used outside in the cold, in the wind. We want to make sure it won't deteriorate over time. When developing our ideas, we kept our design constraints open and tailored our concepts accordingly. As a class, we peer-reviewed each other's final design and gave any feedback to help each group settle on a final concept. Our final decision was also coupled with a decision matrix shown below to find the best solution for our product.
Final design we settled on what we called the roller design, which is the capsule that has the removable scraper and the microfiber cloth. So some of the parts that we really liked about our final design was that it's small and portable, and compared to the others, it's pretty eco-friendly. With the sticker design, we didn't know really how efficient it would be having layers of stickers, like how well you would be able to see, where would these stickers that you remove be going after you use them. And then the cloth in our heated compartment, it wasn't quite rigid enough, and we didn't love the idea of a totally exposed heating element. So between all that, we decided that our roller design was the best way to go. But so you can probably see that between our final design and our CAD model, some things definitely changed. So what we decided to do, so originally the scraper was on a hinge on the side of our capsule, and that moving component was a little too complicated, we thought, for someone who might have mittens on or have dexterity issues. So we decided to break up our design into 2 main components, the scraper and the microfiber casing section. So as you can see, the blue section is the scraper. It's connected by magnets, and it's going to be covering the microfiber section when you're not using either. And what you're going to do is remove the scraper with one hand and scrape away any ice on your goggles, and with the other hand, you will be able to use the microfiber cloth, which is going to be poking out of the light gray section on the back of the capsule. And so you will be able to wipe away any ice or water that you missed with the scraper. So another part to note is that on the bottom is where we're going to be keeping all of our electronics and battery set up. there is a small charging port on the bottom that you will see that allows you to recharge the battery. So you don't have to worry about disassembling the product at all. You can just recharge it for the heating element and you will be ready to go. So this is more of a breakdown of what the inside of our design looks like. The green sections will all turn together. So how you're going to turn the microfiber cloth inside of the capsule is by moving the green section on top, and it's going to be connected to an axle. So when you turn that, it turns the green gear that is attached. So the green section will be moving the red section, and that red section are the rollers that will be connected to the microfiber cloth. And when that spins around, it will always be giving you a clean, dry edge. And the yellow part in the back is the backing of the heat strips that we will be putting to dry and warm the microfiber section.
Once we decided on our final product, what design solution we were going to pursue, we needed to test it out and prototype to make sure that it would work and that our heating strips were up to standard to actually dry the microfiber towel. So right here, we have just a little test to make sure that this heating strip here can get hot enough. We were able to get this up to 300 degrees Fahrenheit, which once we add multiple heating elements, it will be sufficient to dry off a towel after it's been used and has dried your goggles off. Here we have it wired with an LED and a switch. This switch is an on and off button so that the heating element is not constantly working even when the towel is dry, just to save its life and battery power. The LED will allow you to decipher when the device is activated, whether it's on or off, heating up your towel or not. And it is all connected through the heating element. So once this switch is on, the LED turns on and the heating element is activated and it's drying your towel and preparing it to be used.
All right, some of our final objectives was, we wanted it to be well substantiated with STEM principles and practices applicable to all of our design product requirements, constraints, ideas. We wanted it, to be environmentally safe and practical. So we wanted to make sure that we fulfilled all those requirements. So we took and we really looked through our product. We looked for things that we can change. As we showed you, we've switched several things throughout. Like we wanted the turn dial to be able to be used easily for somebody who might have less mobility, either because of a glove or because that's just something that they deal with. So we wanted it to be widely accessible. We wanted to make sure that there wasn't any alternatives out there that essentially did the same thing or even better. Obviously, we want the best solution, and we want to make sure that we're not plagiarizing anybody else accidentally. So all of our reviews and things provide our confirmation and all of our details to show that we've really put in this research.
So how are we going to show that our designs are not just guesses and that our ideas proposed are really based on sound logic and subject-related knowledge? So we have many brainstorming sheets and numerous sketches of the product that have evolved through our process. We've done product research, patent research. We've come up with multiple designs. We've spent a long while CAD modeling, and now we're finally starting to 3D print and test our design. So our solution has merit through all that research and us consulting with the other groups and trying to find the best solution that we possibly can.
Continuing forward, we're going to be using STEM principles that, Continuing forward, we're using STEM principles to test our product and make sure that we have a viable solution. Got it. Going forward, we're going to be continuing to use STEM principles to make sure that we have a viable solution and a product that will be able to put into an open market and something that people will actually buy. We've used electrical engineering and We've gone through math problems to make sure that our design, frankly, doesn't blow up from too much current or voltage. We're aiming to have our product with a longer lifespan so that people don't need to replace it every now and then, and you don't need to throw it out. Obviously, batteries shouldn't be put out into the world or thrown out, so we want to keep them rechargeable and make sure that our product can be used for many years. We'll also be providing replacement cloths and anything else. We're going to make our design very easy to be used. You can take it apart, replace anything you need. Our hope is to have the product last indefinitely, but it must be properly disposed of as an electronic.
So here's kind of a view of the timeline that I mapped out at the beginning of our course. We want to make sure we stay on track, and we want to make sure we get everything done. There is a lot of research and there is a lot of papers and stuff that goes into making this to make sure that our solution is as viable as we can make it. So if you look, we started out with making sure our problem in and of itself was valid, and we showed you that through some of our starting research and some of our surveys. And then we moved into designs, so we showed you some of our later designs when we moved on to trying to pick one. Obviously, before that, we drafted up numerous designs, and we built upon them to get you those three that we then chose from. Now we're starting to move into prototype and testing, so building things like that, and making sure that our design in and of itself works, and figuring out those last few things. So with that, there's building, and then finally just putting together a final project where we get ready to present. We make sure we have all the kinks working, and we make sure we really have the best project that we can.
We thank you all for taking the time to go through our presentation and give us feedback. Anything that can make our product better, we're really aiming to have the best design possible. We know this is not the format that we all wanted. We really would have liked to have a actual Q&A and go together and talk about our product together, but unfortunately the time just wouldn't allow it.
Thank you so much. Please email us with any questions or any further inquiries about our project, and we will get back to you. Again, thank you so much for taking time out of your day to review our project.